Assalamualaikum and hi everyone. We are Group Ghost Code from class CDCS 2514A and today we will be presenting about code review on the Money Tracker application. Our team members are myself, Nurina Damia binti Azrin, Damia Abiana binti Nur Shamsuddin and Farisa Atira binti Ahmad Rohamizan. To start off, let me briefly explain what a code review is. Code review is the process of manually checking the source code of a system to find potential issues such as bugs, security vulnerabilities, and violation of coding standards. For this project, we reviewed the PHP files of the Money Tracker application using Visual Studio Code as our main editor. During the review, we discovered several serious issues, and for my part, I will be explaining one of the high-risk vulnerabilities, which is SQL injection. SQL injection happens when an attacker inserts malicious SQL code into an input field or URL. If the application does not handle the input properly, the attacker can access private or sensitive user data, modify or delete records in the database, and even gain full control of the system. This can lead to data breaches, loss of information, and serious damage to the system's security. Now I will show a short demo to explain how SQL injection works in the Money Tracker application. In our case, the vulnerable file is at transaction.php. The issue is that the code uses user input directly in an SQL query without proper filtering or validation. Here is the vulnerable code. As you can see, the user input is directly combined in the SQL query. This approach is risky because it opens the door for attackers to inject harmful SQL commands. Let's say an attacker types this into the item input field. If the database user has enough privileges, this input could delete the entire transaction table. This clearly shows that the application allows dangerous SQL commands to be executed. To fix this, we use prepared statements with parameterized queries. Here is the updated version of the code. With this fix, user input is safely handled and treated only as data, not as part of the SQL command. Now, if someone tries the same attack input again, it will no longer cause an error or delete anything. The input will simply be stored as plain text in the database, just like any regular item name. In conclusion, this demo shows why it is important to use prepared statements to defend against SQL injection. With this fix, the application is now much more secure and protected from one of the most common web vulnerabilities. So, how do you prevent SQL injection? Here are the mitigation steps. First, we should use prepared statements or parameterized queries. This helps ensure that user input is treated as data, not as part of the SQL command. Second, always validate and sanitize all user input. This means checking that the data is clean, safe, and in the correct format. Lastly, never concatenate raw input directly into SQL queries. This is where most SQL injection risk happens. By following these practices, we can protect the application from attackers and ensure that the system is more secure. That's all from me. I will now pass the presentation to the next speaker. Thank you.
So the next vulnerability is missing password hashing. It's a security measure that converts a plain text password into a unique, fixed length string of characters using a cryptography algorithm. So why password hashing matters? Because an attacker can get a full access to every user's password if the database ever compromised. I've found two vulnerabilities in change password.php file, which are on the line 4, the missing password hashing, and the line 7 for SQL injection. For the SQL injection, while ID comes from the session, the password is directly from user input and can be manipulated, while for the hashing part, anyone who gains access to our database, it can see all user password in a readable form like this. So I've changed to LN12, so you can see it in the plain text form. Now I'm going to fix the code for both hashing password and SQL injection. Now you can see the fixed code on the line 7 and 11 for SQL injection, and save the file. Now we're going to change another new password. So yeah, okay, let's see in the database. Now you can see the password is not in the plain text form anymore. So how to mitigate the password hashing is by using the password hashing to securely store the password. The second one is using password verify during login to check, and the last one, never store the raw passwords in the database.
Hello everyone, my name is Tami Abena and today I'll be presenting one demo on one of the most common web application vulnerabilities, which is cross-site scripting or XXS using simple money tracking system built with PHP. So let's start with the basics. What is XXS? Cross-site scripting or XXS is a type of security vulnerability that affects web application. It allows attackers to inject malicious scripts, usually JavaScript, into web pages that are viewed by other users. These scripts doesn't run on server, they run in the victim's browser. That makes it extremely dangerous because the browser trusts the web page and allows the malicious script to do things like access cookies, steal session tokens, or act as the user. So, how does an XXX attack actually work? Here's a step-by-step example. First, an attacker finds a part of the website that accepts user input like form or comment box. Then, they insert a malicious JavaScript script instead of regular input. Then, the website fails to sanitize or escape that input. When other users view that page, the script runs in their browser. Now, the attacker can steal data or impersonate the user. You might be wondering what's the worst that could happen. Here's some real danger of XXX attacks. First, they can steal cookies or session tokens. They can access user account without login. Second, hijack user accounts. They can pretend to be you and perform action as you. Third, send fake messages. They can trick your friends or customer using your account. Now let's move into a live demo of how XXS can happen in PHP application. We're going to exploit the app by inserting a script into one of the transaction fields. This is the current code in list.php that displays the transaction list. So here I highlight the line 28 and 54. This line is very dangerous because it outputs data directly from the database without escaping or sanitizing. That means any code stored there will be executed by the browser. Let's go to the dashboard and add a new transaction. In the item field, type this word and enter amount and click add transaction. Now when we open the list page, we get a pop-up saying hack. That means the browser ran the script from the database. This is stored XXX in action. We definitely don't want that. Let's fix it by escaping the output. So I will change the correct line of using HTML special characters at line 28 and 54. This function converts characters and into a self HTML entities so they are displayed as text instead of interpreted as code. Let's try the same script again and see what happens. So this time, no pop-up. The script is displayed as plain text. That means XXS is successfully blocked. Now let's go over some practices to prevent XXS. First is escape output. What it means? It means to convert a special character to HTML for a safer version. Why it is important? It is important because to prevent the browser from accidentally running injected scripts. Next, sanitize input. What it means? To remove or clean harmful content from user input before storing or using it. Why it is important? It is important because it will stop dangerous scripts from ever reaching the database. And the last one is use content security policy, CSP. What it means? CSP is a browser security feature that blocks unapproved scripts from running. Why it is important? It is important because even if malicious scripts sneak in, CSP stops them from running.
In conclusion, our code review of Money Tracker application reveals several security vulnerabilities that could compromise both the application and its user data. This issue primarily stems from insecure handling of user input, lack of proper data validation, and missing security best practices. So throughout the code review, we demonstrated how attackers can exploit these flaws and how we applied secure coding techniques to mitigate them. By implementing practices such as input sanitization, prepared statements, and secure password handling, we significantly improved the overall security posture of the application. So this review highlights the critical role of secure coding in application development. Addressing vulnerabilities early not only protects the system but also builds user trust and ensures the long-term maintainability. So thank you for watching. That's all from us. Assalamualaikum warahmatullahi wabarakatuh.